Okay guys, first of all I need to make sure that all of you hopefully get a chance in order to download and install the Postgres, okay? Today we're going to have like a short tutorial, okay? We are going to learn how can we load the university sample database into the PostgreSQL database server in order to allow us to practice the Postgres, okay? So I'm going to show you step by step. The first thing you need to make sure that all the students already installed the Postgres in their machine. Remember the database system concept, the textbook that you work with? This has sample database. This is the link to the textbook. When you see, this is the link to the textbook that you work with. If you take a look to the sample tables, if you click over this link, it's going to allow you to download many tables. The first one that we interested today, we are actually interested in two tables, okay? Or two files. The first one, data definition language. If you download either this link file or this file, okay? I prefer to work with this one, which contains the data definition language, the SQL commands to create tables, okay? And the second file that we're interested to download and work with is SQL code for creating small relation or large relations. I prefer to use this one, okay? So if you download the DDL, if you click over this one, it's going to download one file, and click over this link in order to download the second file. I already download all these files, okay? So that I have these files, okay? The first one is going to be ddl.sql. The second file is going to be large relation insert file, okay? Once you download these files, I'm going to show you how can we create our database first. Then after that, how can we create the tables? Then how can we fill or populate these tables with data? Then we can start working with the SQL, okay? When you launch the pgAdmin, okay? So the first thing after we launch the pgAdmin with a graphical user interface that allow us in order to work with or communicate with the Postgres database server, here you have to type the password. Remember, when you install the Postgres in your machine, you choose simple password. In my case, is 1234. I just click over this one so I can see the following, okay? Check the browser here. In my case, I do have a different version of Postgres. In your case, it's going to have only one, okay? So click the Postgres SQL 14 or whatever the version that we have here. If they ask you to enter the password again, it's fine. And this one is going to have like a database, then have some data or some information. We are going to cover this one later in more details, okay? The thing that we need to focus on right now, how can we create a simple database? If you notice here, we have the default user called Postgres, okay? You can define your own user later. We're going to play around with different users, but this is the default user, okay? Go to the schema, for example, Postgres database, and you're going to see here you have many schemas. So might be public schema and etc. We're going to see later we can create different schema for the same database. Right now, it's not our focus, right? It's the simple thing again, just need to create a new database. Did you see the database here? If you right click, you can choose create database. Let's type university, for example, or whatever name of the database that you want. What's the default or owner of this database? We are going to leave everything right now as a default. And you just click save. If you click save here, if you notice here, we have a new database is created. It's called university. I click over this one, open. You see now we have access. It looks like right now what we have done. We just created database. A new database is called university. Then now we connect to this database after I click over this database. In the schema here, you notice we have a public schema. As you mentioned, we might have a multiple schema. Here we're going to see all of them, most of them later when you work during the class. I'm going to show you how to create a procedure. I'm going to show you how can you create a function so that can you use within your database, okay? If you take a look at the tables, you see that there is no tables. Remember, we said that last time. When you create a new database, it's going to be empty, nothing there. So how can you populate this one? How can you fill data or create my tables? Or in other words, how can you write or type my queries? We have a simple thing. I mean, I prefer using the pgAdmin because it's easy to work with. Did you see here? Click over this icon, okay? It's called query tool. You have to be in your database that you want to work with. So now you have to click any place within the university database, okay? Then you click the query tool. This one open you like, a place allow you to write or type your query, okay? So how can you type my query? The first thing, I need to create tables. Either you're going to start typing the queries that allow you to create the table, or Remember, we have the data definition language that we just download from that website. Click over that file, okay? Then just drop the file here. So you know exactly where this file that is going to be stored, of course. You download somewhere, yeah? So click over this, drag and drop this file into this, query editor. If you take a look, this is a system going to automatically show you this one. I download the different files. What I download, drop and just say create. So that's fine. This one, in this case, the first command is, if you take a look here, if you already have these files or these relations or these tables already there, delete them first in order to create them, come up with a fresh, creation of these files. Okay? So if you take a look at this one, you see that create tables, enable the tables, attributes, specify which primary key, which foreign key, and etc. for all of them. Okay? Again, drag and drop that file, the data definition language. Now you want to execute this one. You want to run this one. Here you check here, you have this icon. We have the right arrow. Okay? Allow us in order to execute. If you click this one here, you see it's going to tell you, for example, what's the result. Here, because we don't have the tables as exist before, so you're stuck here. Let me remove the drop tables here. I don't need them. So let me run again. You see that create table and the query return, they give you the time spent in order to write or create your tables. All of them, okay? If everything is fine, click over the tables here, okay? Maybe you need to have, do a refresh. Right click, refresh here, make sure that whatever you have done is going to take effect. Then you click at the tables to see that now we have a tables here. Now those tables are empty. There is nothing there. The only thing we create the schema, okay? Then what I'm going to do here, I can either create another query tool because I need to perform like some insertion, okay? So we are lucky because the textbook provide us with another file which allow us in order to populate the data with some data, okay? So again, either create another query tool or maybe I'm gonna Control A and erase everything. So now the query editor is blank, nothing there. So back to the file. Remember that we download two files. The second one is called large relation insert file .sql. Okay, you can drag this file, then drop it here. If you drop this one, you see that you see that you have many inserts. Of course, this is not an optimal way to fill your data or populate your data with large amount of data. But for this class, that's fine. Okay, the only thing I change with the data, maybe I'm gonna bust this file to in the blackboard or to the blackboard because the data that's installed in the textbook contains all data. What does that mean? That means when you try to find, for example, all the course offered in the fall 2017, there is not 2017. I think the year from 2000 up to 2010. I modify the data in order to have the years going to be from 2010 up to 2019, okay? Anyway, so I need to run this one. Just to click over this icon. Now the query, it depends on your speed and your computer and connection. So here it takes time, whatever. Then after that, now the data can be stored. I don't need this one, so I can maybe Control A and delete everything. And now if you take a look, for example, whatever, let's take a look to the department here, okay? The simple thing, let's check whether we do have a data populated there or not. You can say select, okay? In here, whatever the query that you want to type, use the query editor. Select, for example, star from, let's say, instructor. I know, I've said the department, then I choose the instructor, whatever. You click here, run, and this is give you the result. You see, now you can see how many tuples there. For example, 500 tuples, and those are the data here. You see? Make sense? So we managed to create our database. We create tables. Then after that, we fill this one with data. Clear? I do have one file. I'm going to share it with you, okay? This file is summarized. A SQL file contains most of the command that we cover in the chapter 5. Which is the one that we will try to start working on that. Okay, it's going to be chapter 5, November 4th. I will upload these files after this tutorial. Okay, when you open this one, this is just to show you, I mean, what's the command that we need to execute. Okay, because I'm a lazy guy, I'm not gonna type every single instruction. Then I'm going to open another query, I mean, editor. And now I can switch between this and this. This one, like the file that contains all the commands that we'll try to cover, we can play around, work with, to practice, make sure that we manage to how to connect to the database. We manage, for example, how can we extract some data. Okay, so the first one here is I'm gonna copy from here, from this query editor, and I open the second one. I just open it here. I can use this one in order to extract my query. Copy and paste. So select count distinct ID from the instructor. So this command is going to do what here? Remember the execution, or the order of the execution here. So start or evaluation of the query. Start with the from. Then after that, for every single tuple, it's going to display, I mean, a count. I mean, how many distinct ID do you have? Sorry, this is counting. This means it's going to count just the entire relation here. Okay. How many tuples or distinct ID do you have? Since the ID is like the primary key, so in this case, there is no duplicate value. So you see the total is 50. If you remove, for example, distinct from here, that means if you have a duplicate ID, consider them in the result. But remember, the ID is the primary key, so no way we have a duplicate value for the ID. So result still going to be 50. Okay, let's take a look at the second command here. What if we try to have, remember we talked about this one in the class, we said we need just to extract, let's say, the number of departments that we have from the instructor. The first one, I'm gonna remove, the distinct. Okay, so you have a select count between two parentheses, you're gonna write whatever the attribute you wanted to count based on, then after that from which relation. When you execute this one, you see that the number is 50. Okay, why? We do have a duplicate value here. Okay, so what if I said distinct here? So the number of departments is going to be much less. See, it's going to be 17 maybe. Make sense? Because the department name is not, let's say, unique value. It's not primary key in the instructor relation. Yeah, and we have there's a chance, or we have to say, the situation that we have many instructors that work in the same department. Okay. In order to make sure how many departments do we have here, let's say count the number of departments from the department relation. My keyboard is the right one, hopefully. Execute again. Yeah, you see you have a 20. Someone gonna say, what does that mean? That means there's some instructor, we have some departments, the department relation, but maybe these departments they don't have any instructor work at these departments yet. Make sense, guys? So far, so good? Okay, great. So let's take a look here. How about if I wanted to use, say, the alias, as we did last time, okay? How about I create an alias? What's the name of alias? Give this command or this whatever count a name, okay? So the temporary name, right? When you run my query here, you see that's going to be here, the department count. If I didn't specify this one, by the way, let's say do like this. This like comment, right? So the query is not going to be executed. The SQL is going to ignore this part. Let me run this one here. Oh, yeah, sorry. It's going to ignore everything, I believe. Yeah. You see here, the result or the name of the result or the attribute or column that you produce based on this query, maybe you cannot control what the name is going to be here. So that's why we use an alias in order to make it, for example, department count is better than count or whatever. Maybe sometimes it's going to try, for example, question mark column, another question mark. So we cannot guarantee what's the value going to be. That's why we are going to use an alias here. When you run this one here, don't worry, do this one again. What's happened? Sometimes the system, when you try to execute the same command, I know what happens, so I'll try to do this one again and again. You see, I didn't change anything. Maybe there is a space, maybe something hidden because copy and paste, so I'm not sure what happened here. Okay, what if I want to have a name or alias that have space or maybe compose more than one word? In this case, if you want to perform that, you have to write this one between double quotes. Okay, remember we said that before? Now the name of this alias or the alias name of this column is going to be department space count. And this is what we have. Okay? So let's go forward here. Let's have this interesting command here. Find the average salary of the instructor in each department. Okay? So that's what we did here. The average salary in each department. This is my command. You see that limit 3, by the way, you can use this one in order to specify how many tuples you want to display. So ignore this one. We're going to cover this one later. So what I've said here, select department average salary from the instructor. Go by the department name. When you execute this one, and this is the result going to be something like this. You see that? It's going to group the data based on the department. And for each department, we're going to display the average salary. Okay? If you don't like the format, the average salary is going to be displayed. So maybe you can use, for example, I believe we have around one function. You can use around this value, whatever the aggregate function, comma, how many decimal, or say digit you want to display after the decimal point. Let's say 2. I know we didn't cover the round, but it's just to give you something that helps you in order to organize, the outcome that we have. And here you see, we specify that we have only 2 digits going to be after, or 2 decimal, or 2 digits after the decimal point. Okay, something interesting, at least something give you, control the format of the outcome. Remember that we said it's not required in order to specify the go by attribute in the select, right? But if there is any attribute going to be listed in the select, and this attribute wasn't used in the aggregate function or the go by, so the system cannot tell, cannot have unique value, okay, unique way of choosing which this value for this attribute. Let me give you this command. What I've done, the same thing. I try to display the average salary per department. Then I mistakenly add the ID here. By the way, you notice that sometimes have a semicolon, sometimes not. PostgreSQL is smart enough for the pgAdmin, even if you didn't specify or write or type the semicolon, it's going to accept this query as, let's say, a valid query. So here, select department name, okay, ID, I know what's the ID is going to be here. Average salary from the instructor, group by the department name. You divide your data or group your database with the department name. Then you said I wanted to display the department name, and for example, divide the data or group them based on the department name. The problem here, which ID you're going to display, for example, with the department name computer science or with math. There's no unique way, even if you have only one single ID. Okay, so the system, again, in this case, if you run your code here, it gives you like a hint in the error. You said, for example, there is an error there in this value that we have here. Let me say, do this one again. It's not the error that I'm looking for. Remember, I'm copy and paste. Maybe there's something hidden there. Yeah. Because what I'm doing, copy and paste from file and try in the editor. So maybe I'm copying, maybe there's a hidden character. Anyway. So you see that the system told give you an error message, and they said here the instructor.id must appear in the group by clause or be used in the aggregate function. So we cannot do this one like this. Make sense? Okay. So let's take a look at this example here. If we said find the names and the average salary for all the departments who the average salary, let's say, is greater than 42,000. Remember we did this one in the class. I will copy this one, then I'm going to show you one interesting feature in the Postgres. Oh, this is a pgAdmin, in general. Okay? Let me run my query first, and this is the result. Okay? I use the round the average salary comma 2 in order just to make easier to read for the average salary. What if, by the way, the order of execution clear, right? Evaluation, how the query is going to be evaluated. First, you have a form. Then after that, group the data based on the department name, compute the aggregate function, right? Then after that, you're gonna perform what? You're gonna perform, if you have a having, you're gonna be executed. Then after that, you have select. Then after that, whatever gonna be executed, gonna be the last one based on the command or query that we have. It's gonna be the last one. Gonna be the order by. If you notice that I used, the alias here in the order by, which works fine, because the order by is gonna be executed when. After the select, not before. Okay? Let me play around and show you the simple thing here. If you just highlight whatever portion of the query, okay, and you said execute, so the pgAdmin is going to execute only the highlighted part of the query. So it looks like now you need just select department name and the average salary from the instructor, go by the department name only. If you run this one, and this is what happened here. Even you see that how many tuples can be affected in this case. Makes sense? Sometimes it's going to be helpful. Sometimes you have a complicated query, so we can do this technique. We can highlight maybe part of the query in order to imagine, in order to see what's the result it might be if only I execute this part of the query. Make sense? The other thing here, let me play around. How about, let's try to use the average salary. I'm going to use the underscore, okay? Just to make sure that's easy to work with, okay? Let's watch this one here. And so here you have to use the average salary. And this is descending order. That means you have to, organize the data in descending order, the highest average salary first, okay? And you can play, you can test your data. For example, I'm looking for the average salary greater than 85. Let's say change this one to the 85. Just to see whether it's going to exclude this data or not. For example, the marketing. If you run the code, so you see you have a list data, and all the average salary must satisfy this condition. This is one way in order to figure out to see whether your query makes sense or not. Okay? One thing here, how about if it did something like this? What if I said I use it? What do you think? I change having from instead using the average salary, I use the alias that I define here for the average salary for the select. So what do you think? Whether the system is going to accept this one and allow us to execute this query, or say no, there is a mistake? Let me see. If you run my code here, the system say, wait. You use the average salary, yes? This one as what? As an alias. At this moment, when you try to execute the having here, we don't know anything. The average salary does not exist yet. And this is query, I like, the way that the database management system or the database system that we use give us some hint, okay, about the error. So help us in order to make sure how can you fix this one. You see that they said the column average salary doesn't exist at this moment in the having. So we cannot use this one. So just this proof, convince us or prove that the way that how the or confirm how the database management system is going to execute the query based on which order. Okay? So if you change this one to the average salary, so the system is going to do. Sometimes you have to do this one or twice. Sometimes I know what's exactly happened here, back and forth, then it's going to be executed. Although there's no error here, but I know if you type something, so system maybe add maybe weird hidden character somehow. Okay. So we did this here. Let me jump to, we did this one here. Find the average salary each department. We did this one. Find the average salary of instructor at each department. Let's do this one here. That's interesting. At least we have different story tools, different query. So copy paste. You see that? Select. I just use, remember we use the upper, the lower, and something like this. I want to play around, okay? So ignore this part first, okay? Let's leave this one. We have a function, it's called upper. Whatever you have the input for this function, this function is going to change, the letter to the uppercase. All of them are going to be uppercase, okay? Round, what's the round here? Just say, comma 2. Okay, only you need 2 digits after the decimal point. From the instructor, go by the department name, order by the department name. Okay, so let me do this one without the order. I run my code. So this is the order that's shown to me, okay? Okay, in order to make sure that I wanted to order them by the department name, so I'm going to execute the entire query. You see, this is, by default, it's going to be ascending order. Yeah, if you want a descending order, that means DES. Another thing, let's play around. Remember I said we have upper, lower, and etc. Okay, assume that we have the data have first name, middle name, last name. Then you wanted to create one column that contains last name, comma, first name. Okay, how can we do that? Although we don't have enough data here, but I'm gonna play with the department name. Assume that we have upper, you need to display the upper letters for the department name, comma the lower letters of the department, or department name in lower letters, okay? So I can use concatenate, remember I said this one here. Then I can use here concatenate with the space, comma. Then after that, you say concatenate with the lowercase of the department. Yeah, of the department in the lowercase. Okay, and you have a comma here. You imagine, you see that what my query is going to be here? So this one is going to be only one column. Why? Because I concatenate them in one, connected together, the whatever, the uppercase of the department name, comma, the lowercase of the department name. If I didn't use this one, add this string, so it's going to be the upper, the lower department name is going to be next to each other. There is no space. Let's run this one here between them. Okay, this is something here. Yeah, it's weird, you see? I didn't do anything, but just like delete whatever character might be there. Anyway, so you take a look here, you see that, the name, accounting uppercase and accounting lowercase. What's the name of the column? It's not clear. So in this case, let's say all names. I know a weird name. I just give an alias here and see the name of the column is gonna be all names. Okay. What else here? We know this one, so it's easy. Let's take a look at this one. How can you use a set operation? Okay. So here you need to what? Find the costs offered in the fall 2018 and spring 2018. Okay. We did this one using intersection, right? And it doesn't hurt if you take a look at the intersection here. So in the intersection, remember I said I leave spacing and indentation here. Just in order to make sure my query makes sense. By the way, you can write your query in one line, but it's going to be hard to read, right? It's not going to be clear to anyone what's going on. So that's what I've said. This one query intersect with another query. So all the tuple, in order to be part of the result, must be here and here, right? And let me run the query, and the result give me only one course ID. Okay, in order to see how it works, let's take a look here. What's the result of this part? I just highlight, the first part of the query, or the query number one, which just, do what? Find out all the courses that offered in the fall 2018. Okay, if I run this one, this is going to be give me 158. So this one going to be produce only one course. How about the second query? I need to list all the courses offered in the spring 2018. By the way, it depends on the data that we have. Keep in your mind that, remember that the first one produced 158. If you run the second one, now the second one produced those, the following list of the courses. Okay, so in order to find intersection, it looks like the 158 is the only common, course ID. Okay. So using this technique at least help us in order to understand what's going on. So we can tell this is the result for this this query, this is the result of second query. So I can't confirm the intersection can be what can be both of them. Okay. Let me see how can you do that using the subquery. And the subquery. Okay. And here I'm gonna use what set membership or set membership test. So what does that mean here? We're going to say, for example, one attribute is in what? Whether it's going to be member in one relation or not. So what's the first part here? Only display all the costs, from the section offered in the fall 2018. And I highlight this one. So the enforce or tilde system, I need just to know I'm trusting only the result of this part. Okay, what's the inner? Or the subquery? Check this one, give you all the list offered in the spring 2018. So I said this course on the outside here, or the outer query, must be in this list. So the only course in this list is going to be what? 158, all right? So this one is going to be part of the result. Just a quick reminder how the subquery is going to be executed, evaluated. First, the subquery is going to be evaluated, get the result, then the result is going to be passed to the outer query. So the outer query is going to have something like this. Assume that this one is going to be here. N. Make sense? And this is the run, give you the same result. So either use intersection or use one, or using subquery can produce the same result. Another thing, enumerated list or sets, you can use this one in order to compare your query. Let me just copy and paste this one. And this piece first. What's the result here? It's going to give me only the distinct names of all the instructor here. Okay, and here we're not in these guys. How about add another one? I'm gonna use poor guy yin. Okay, I add this one to the list. So I need to exclude this one. If you run the code here, the system goes, oh, we don't have this guy. This guy. Make sense? Okay. Let's take a look. Remember that we said find the total number of the distinct students who have taken course section taught by the specific instructor. The only difference is that that's what you did in the class. In order to make sure there is an instructor teach specific course, I change this one to randomly choose another instructor. Okay, so the only difference, I need to change the instructor ID to make sure that we have a result. Okay, copy and paste here and see how it works. Again, when you see subquery, it's easy. Take a look here. What's the result here? Give me the course ID, section ID, semester, and year. The taught by specific instructor. I give you the teach ID equal this value. I get this information from the teach, which could, table or relation that keep tracking all the courses taught by every single instructor. When you run this one, those are the courses that taught by this instructor. Okay, good. The first one here, give me what? All the course, or count the course taken by every single student. I need just distinct ID, where the course ID must be in this list, the section ID must be here, the semester and year. So it looks like you need to figure out to find out all the course taken by every single student. So I have to go to the takes relation, which is gonna capture or keep tracking this kind of information. For every single tuple, in order to be counted as a student, in this result, I need to make sure that this student take this course with that instructor, which is going to be listed here. I'm not going to compare only one attribute. I'm going to compare, in this case, 4 attributes, which 1, 2, 3, 4. Okay? And I know I've said it's 30 minutes, but I'm going to continue. So if you have something to do, you can leave right now. That's fine. Okay? So remember that we said have simple query, which allows in order to find the names of instructors, okay, with the salary greater than some of, let's say, instructor in the biology department. And this is my query that we did before using subquery. What I'm going to do here, I'm going to use, let's say, in this case, I need, by the way, to do set comparison, right? We have a value, it's going to be compared with a number of values. It's not whether this value of this set of values is going to be a membership in another relationship. So here, what's this? Going to give me this part of query. I highlight only this one, okay? When you run this one, it give me all, let's say, the salary of the instructor in the biology department. We have only 2. Great. And here, I need to find or select all the instructor where their salary must be greater than this salary. Okay, so must be greater than 45,000, greater than, at least some, not all of them. Okay, that's why I can say some greater than some, or you can use any, either is fine, by the way. Okay, when you run my code, this is the result. Might be not clear, so what I'm going to do, I'm going to add the salary here. Just display the salary in order to make sure it makes sense or not, you see? So this information is going to give you some hint here. Okay. I will jump to go with all. You can do the same one. So you just have a salary greater than all. So this means this value of the salary must be greater than every single value produced in subquery. Again, just to remind you, the subquery, execute the subquery first. Then after that, the result is going to be passed to the outer query. Let me check, exist or not exist. Okay, so I need to find, for example, all the costs taught in both the fall 2018 semester and in the spring 2018. When you write your query here, remember, you can do this one by the easy way, all right? Let me write this one here just to make sure that it's going to be clear. Maybe all the code is going to be the same place. Okay, and it's just in order to make sure that it makes sense to us. Okay, clear to read. Again, you can write all the whole query in one line. What kind of a query here? We call this one correlated query. Correlated query, as we mentioned in the class, has different way to execute, to evaluate. Okay, for the subquery, evaluate the subquery, then after that, pass the result to the outer query. For the correlated query, which you're gonna have what? You are gonna use an attribute that belongs to the outer query within the subquery. Okay, so what I've said is select the star from the section, for example, where the semester equal spring at 2018. I'll just highlight this part. This is going to produce or select all the courses that are offered in the spring at 2018. Okay, but I need to do what here? Back to the my query here. He said the course taught in both fall 2018 and in spring 2018. So in this case, this part is going to produce only all the courses taught in fall 2018. All right, And I need to make sure this course, in order to be part of the result, must exist in this subquery. In order to evaluate this one, the system for the correct subquery, as you mentioned in the class, starts with a tuple by tuple from the outer query. For every single outer query, we're going to use this. We're going to use the subquery in order to evaluate, in order to tell whether the tuple from the outer query is going to be part of the result or not. So here, take a look here, for example. When I run this, we have only one course. If you assume that we have multiple courses, okay, maybe 2 or 3, okay. Let me change this one. Maybe have something here. Maybe have more. Oh, we have only one. Let me check this one here. Oh, I like this one. You see that I just modified this one to 2016 in order to try to explain the idea. So here for this course, for first part, we have 8 tuples, okay? For each tuple, in order to make sure this tuple is going to be part of the result or not, I'm going to use this value. I'm going to be evaluate, use the subquery here. So now the course ID from the s.course ID is going to be 239. And here I need select, start from the section, from the course, for the section, sorry, where the semester equals spring and year 2018. And at the same time, the course ID must equal 239. If this one exists, what does that mean exists? If the inner query or the subquery produce at least one tuple, then the result is going to be evaluated to the true. So yes, this course is going to be part of the result, the 239, something like this. Let me run my code, the query, and this is the result. Make sense? Remember this one? We've said to try to find all the students who have taken all the courses offered in the biology department. Let me copy and paste this one here in the query editor. Then you see here, we said not exist. I need to make sure that this student take only display the information about the student who taking every single course offered by the biology department. How many courses offered by the biology department? Let's recheck here. They have 7 courses. So in order to start with the top here, select star from the student here. Let me run this one. We do have, for example, how many students? We have many, okay? 2,000 students, okay? So for every single student here, what we need to do here, we need to make sure that whether the student has taken every single course offered by the biology department. So I'm gonna use the correlated query. This part, just take a look and produce a course offered by this student or taken by this student. Here, this part is gonna produce or display or come up with all the courses offered by the biology department. When I say except, this means the set difference. We don't have a difference here in the SQL. All the courses in this part, in the biology department, but not taken by a student. If I found anything left, this means student didn't take every single course offered by the biology department. I don't care whether the student take other courses or not, because I'm trusting whether to check whether he or she taken every course offered by the biology department or not. So not exist, that means if we have the result, it's going to be empty here. That means that's what we're looking for. The result is going to be evaluated to the true, and this course student can be part of the result. Sometimes we have what here? We have a blank. If you have a blank or empty, it doesn't mean that your query is bad or wrong. Based on instance of the data, this is the result that we got. Okay? So maybe you can play around, change this one, different department, and see. Hopefully one of them give you a result. I think we have 2 things just to go over. Remember I said, the result of the exist clause. It's going to evaluate to the true if the result of the subquery is going to produce, null value, right? And that's what we did here. I just modified this one here. I create weird command or query, and the inner query I've said only select null. This produce null, okay? Then when I evaluate the entire query here, it looks like the system display every single instructor or the names of all instructors here. So why? Because here this query is going to be evaluated to the true. Why? Because this subquery is going to always produce null value, which is going to be evaluated to the true here. Okay. I believe we need just to go over the unique. Remember that we said sometimes you need to check, okay, whether the subquery is going to produce unique value or not. So we can use unique, okay? This is based on the standard, but we mentioned that last time. Not every single database management system implement this one, including, the Postgres. If you try to do that and run your query, the Postgres is going to say, okay, unique predicate is not yet implemented, so you cannot use it. So how can you solve this one? We said that, remember that? We use this command. We count the number, remember we try to find the cost offered at most 1, 0 or 1. So this command is going to produce a count how many times this cost offered to say, okay, 2017, right? How many times? I count this one, and if the value 1 greater than or equal this count, then it's going to be the result, part of the result. The count is going to have a 0, 1, 2, 3, and etc. Okay? We run here. If you have any course, yeah, we do have. And you can change, for example, at least or at most 2. You can change one. At least 2. You just change, the result that we have. We don't have. Okay? As I mentioned again, sometimes based on the instance, this is the result that we have. Remember that we said when we work with the subquery in the from class, some database management system require from you in order to do what? In order to create or type, let's say, an alias, give an alias to this relation. That's what we wrote this one, without an alias. What we did here. This part is going to just produce, the department. It can be the average salary per department. If we run this one, this is a subquery. Okay, this one is going to be a relation. So what we see here, this is the input here. This is the from. From is going to be X have relation has a 2 columns and filled with this data. So now we can apply or run this query without using having. Remember, we solved this one or answer this one using having here. If you try to write this one or execute this one, here we have something weird for the Postgres. They said, oh, you have a subquery, right? And subquery within the from class, you cannot use this one without an alias. So you can say, for example, as A, B, C, whatever. Only add this one as alias. Although we are not going to use the alias, you can use abc.average. So you can rename the subquery name or result that we got here, or the relation. And this is only for the from class. You have to do that. And when you run your code, the system is going to perform this one. Don't worry, there's something, maybe space here, maybe there's something, yeah. As I mentioned, copy and paste maybe kills an issue here. Anyway, with the class, which is the most important thing I need just to make sure that we understand how to work with the width. Width allows us in order to create, let's say, temporary table, yeah, or relation. Okay? Common table expression. We talked about this one last time. It's like a binding the subquery with a name or temporary name we can use in the same query. So here, just to create the first one, width, whatever the name of the relation, okay, that's temporary relation or the CTE, or to say a common table or expression that we need to build. And here you can specify an attribute here, okay, if you want. And here you have to write your subquery between 2 parentheses. Okay, so this relation or temporary relation is available, visible within this query. Okay, so the width class, when you create a width, create a temporary relation, you have to use a select from where or whatever, any query. You have to use this one here. Otherwise, it's not going to be available after that. When you run my code here, so here show me only the query that has the maximum budget. Here you can play around. You can say, okay, it's going to be budget. Name of the relation is budget. Okay. And here I'm going to call this one as value or whatever. That's fine. Either is fine. You see, either is going to be fine. Either you can specify what the name of attribute here, or you can use, alias here. Okay. Another one, we still have to take a look. For example, if we have, let's say, can we use multiple, let's say, common table expression within the width class? Create more than one. How they are going to be visible to each other. So here, for example, the first one, create a department total. It's going to be what? It's going to compute what? The total salary per department. And this is, you can highlight this one. This is the result. Okay? The department, then you have to give you the total salary as a value. By the way, I'm using values just for simplicity. You can use whatever alias. Okay? So this one is going to be create a department total. Department total is going to be available, visible to any other, let's say, common table expression that we have in the same query. So I can use this one, the department total, here within the department total average. I need to compute the average total per department for all the departments. I do have the salary per department, so I can access this relation in order to compute the average salary, right? What relation I access? The department total is just, create or just, define here. By the way, there is a many easy way in order to answer these queries, but only the reason we use the with or complicated way to answer these queries to show you that how can use different techniques, how different clauses in order to achieve this query. Okay, and here you can run this one, so this is the result. Okay. Yeah. One more quick thing. I'm gonna show. I'm gonna show you the simple question. Okay, query. I'm gonna create a table. Okay, just to give you an idea about the insert. Then after that, the rest you can do this one. You create a table. I use if not exists. That's nice thing. That means if the table does not exist, create it. If the table exists, please don't touch it. Don't do anything. So I run this one, and now it's gonna tell me create a table. Okay, good. I'm going to fill this table with data. Okay, and this is the way how to perform insert. Insert into the table and the value 1, Alice and 20. When you run your code here, you notice that this is the result. The query is gonna say insert 0 and 1. What does that mean, 0 and 1, okay? 0 and 1 is like object ID and count, how many tuples has been inserted here. This is used to be an internal representation of the query, or the tuple inside the Postgres, but they are not used this one anymore. So you're always find the first one always 0, and there is the second one tell you how many tuples has been inserted. Okay, there is another, you can have another class, okay, which allow you, within the statement, or another option, which allow you in order to what? In order to give you like return, the information of the inserted tuple, okay? For example, by the way, can I insert the same one? No, because the first column is represent, the primary key, so I cannot insert the same data. Let's say pop, different data, yeah, and the number is 90 here, whatever. When I say returning star, that means give me the entire tuple. You can specify whatever attribute you want to return. So this one I'm gonna tell you, it's like echo back. Whatever you did, it's gonna give you the result. The outcome. So you see here, I'm inserting a new tuple. The ID is 2, the name is Bob, and the age is 90. So that the information can be listed here. Okay, makes sense, guys? One more thing, last one actually, I promise. If I delete something, I wanted to delete, for example, the first tuple, or this value. Either I'm gonna use returning. Returning is a nice thing. For example, I need just to display the ID and the name from whatever tuple that I'm going to delete. Okay? When you do this one, you're gonna say, okay, this the ID is 1 and the name is Alice. That's all, guys. Hopefully, at least give you an idea how you can, upload or load or create a database under the Postgres, how you populate this one with data, and how can you work with this one. Okay, thanks, guys. See you next week.